Alright, hey guys. So today we are going to be going through lesson 26.2, which is graphing the sine function. So our targets today, we want to be able to graph the sine function in the form y equals a times sine of bx. And then we want to find the period, midline, and amplitude of our sine functions. So just like yesterday's lesson, we learned that kind of what the period is the length it takes to repeat. The midline is that kind of equilibrium right in the middle. And then the amplitude is the distance from the midline to the maximum, midline to minimum. So as you can see in your books, in the My Notes column right here, when I delete it out, is all of the unit circle values. So hopefully those look familiar. And what this graph is doing is they're taking all the y-coordinates on the unit circle, which would represent sine, and they're graphing those as just ordered pairs. So those angles and radians is like our x-axis. Our y-axis is like the output, so the 2/2, the 1/2, the 1. And so you can kind of see all those different points graphed on there. And then what you'll notice is that this function is periodic. So it's going to repeat every 2 pi. So here's one cycle of the graph. And then once we get past 2 pi, it just repeats itself again. Just like you would do with coterminal angles. They have the same values, no matter how many times you go around that circle. So whenever I graph these, I always think of my quadrantal angles. Are 0, pi over 2, pi, 3 pi over 2, and then 2 pi. And those points, so this is the point 1, 0, 0, 1, negative 1, 0, 0, negative 1. So the sine value is taking all the y-coordinates. So we've got our quadrantal angles. And then the y values. So we've got at 0 degrees, the sine is 0. At pi over 2 degrees, the sine is 1. At pi, sine's back to 0. At 3 pi over 2, sine is negative 1. And at 2 pi, sine goes back to 0. So now where I sketch my graphs, I start with those 5 key points. 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0. And that's where I'll manipulate and kind of shift my points from. So another thing that's kind of interesting, right, the sine graph is having that period of 2 pi that repeats every full circle. Its midline would always start off as y equals 0, and the amplitude is always 1. And the sine function is symmetric about the origin. So that means if you rotated it 180 upside down, it would look the exact same. So we call that an odd function. So an odd function tells you that the sine of x and sine of negative x are additive inverses. So if I had the sine of x being 1/2, the sine of negative x would have to be negative 1/2. So they'd cancel out to 0. That's what additive inverses means. And this isn't a very important idea at all, this last little part. It's just referring and kind of reminding you guys of what's an odd function. But big idea here is just being able to graph the sine function, the parent, understanding that we're plotting the points from the unit circle. So what I want you guys to do now is try out the check your understanding, and then go ahead and check your answers on the slide that comes next. Thanks.